Hi Math 2 students. So in this video, I'm going to go through the 6.3 Day 2 homework. Feel free to try these problems before we do them together in the video. But you know, if you're struggling, obviously the video is here to help you. All right, so let's go ahead and take a look at number 2. So when we're looking here, one thing I want to do, I want to change this problem. We're going to make it so that only these angles are congruent. Let's do that. So if we're looking, we can see that angle A goes with angle R. All right. And then we can see that this angle goes with this. AXB goes with RXQ. Okay. So we've got two angles congruent between these two triangles. So that means that we can automatically go ahead and say that these are similar. And these are similar by angle. Now we have to go ahead and write the similarity statement. So when you have congruent angles, it's a little bit easier to write the similarity statement because you can see that angle A goes with angle R. All right. And then here you can see that these two X angles go together. And then what would be left then would be that B and Q go together. So when you write the similarity statement, you have to put it in the proper order. So we're going to say triangle ABX is similar, need that little similarity symbol, to triangle. And you have to do it in the same order, right? We're going to do R, Q, X. And notice how it followed the pattern, right? B and Q go together, A and R go together, and X and X go together. All right, so that would be our similarity statement. All right, next let's go ahead and check to see if these triangles are similar. All right, so looking here, we clearly have three sides, so we're going to attempt to use side, side, side. Now, in this case, it doesn't tell us which sides go together, so this is very important to pay attention to. When it doesn't tell you which side, when it doesn't give you a similarity statement to begin with, what you want to do is this is kind of the method I always teach. Look at the big triangle, find the biggest side of the biggest triangle. So the biggest side of the biggest triangle is going to be 20, all right? Then you go to your smaller triangle. Find the biggest side of the smaller triangle. That's going to be 15. All right, so we put the 20 and the 15 together. Then you find the next biggest side on your big triangle. My next biggest is 16. And you find the next biggest side on your small triangle. That's 12. So we'll do 16 and 12. And then you put together the small sides. Oops, that's supposed to be a highlighter. It's still erasing. So you've got 12 and 9. So we're going to go ahead and calculate this out. So we end up with 20 divided by 15. And I got 1.3 repeating. 16 divided by 12. I got 1.3 repeating. And 12 divided by 9, I got 1.3 repeating. So these are all equal. So they are in proportion with each other. So this would be similar by side, side, side. Okay? Now, this is where it gets tricky. So this is writing a similarity statement. Okay? So what you have to do here is I would kind of highlight the sides that go together. So obviously these guys go together. All right? And orange, these guys go together. And then these guys go together. So basically the way that I tend to teach this is just you have to kind of follow the same route, right? So let's just name one. We'll start with, how about we do the big triangle? Let's just name it AWL. So the path that we took is we went through green, then through purple, okay? So we need to go through green, then through purple, all right? We start at green-orange, go to green-purple, and at purple-orange, right? So we're going to start at green-orange, so we get X, so similar to triangle X. And then we go through green, and we land at purple-green, so we get a P there. And then we go through purple, right? That's what we did here. And we land at purple-orange, which gives us M. So we get XPM. So that's very tricky. And we'll do some more of those. But basically what you have to do is you have to make sure you're going through the same sides at the same time. All right. All right. And I guess another way you could kind of look at it is, okay, orange and green. So A goes with orange and green here. A goes with X, right? That's one way to think of it. And then you look and you're like, okay, green and purple, we've got W. Green and purple, we've got P. Notice how those align. Then you've got purple and orange, M and L. All right. So that's another way to kind of look at it with the angles, which now that I'm thinking about it, that might be an easier way to do it. All right. So let's go ahead. We're taking a look here. Now, if we're looking at this pair of triangles here, we actually only are given two sides, right? We're given this pair of sides and we're given this pair of sides, right? So there's no postulate called side, so we need to see if we can either do a side or a side angle side or something along those lines. Well, if we're looking, I see an X there. We've got vertical angles, all right? So it looks like we might be able to do a side angle side. But first, before we say side angle side, we need to make sure that we prove that these sides are proportional. Now, since we're doing side angle side, you actually only need to show that two sides are proportional, the sides that enclose the angle. So if we look, we're going to use the same method we did on this other one. Remember how I said biggest side of your biggest triangle over the biggest of your small triangle? So it's going to be 8/4. And then your next biggest on your big triangle, and then your next biggest on your small triangle. So that's 4/2. So when you divide that, you get 2 and 2. They are proportional. So now let's go ahead. Let's actually, I should have highlighted these to begin with. These guys go together. These guys go together. And then we've got red and red. So now let's go ahead. We've got our green angle here, which we know correspond. And then you can see here, this angle is going to go with this angle. It's red, and I guess we could, here, we'll even put another color there just to overlap them. We'll put blue. So we've got our red and blue angles. So those correspond. And then we've got our blue and green angles. So those correspond. So when we write the similarity statement, we need to make sure we put those in the correct order. So we could name the big triangle first. We'll say PQM, triangle PQM is similar to, and oh, I'm running out of space. That's okay. Now notice P is this purple guy. He's going to go with B, right? And then Q goes with A, and M goes with M. So BAM. So again, you have to make sure that you're paying close attention to the organization of those letters. All right. So now let's go ahead. I see two angles in one triangle, two angles in the other. Let's fill in the rest of the missing information. So we could do 180 minus 20 minus 30. And that gives us 130. And then we could actually stop here. We've got angle. You could go and calculate that the other missing angle is 20, but we've got angle, so we're good to go. So now I feel like for the angle ones, the similarity statement is just way easier. So we'll go ahead and label this first triangle. So we get triangle MJN is similar to, and then M and A go together. So it's going to be triangle A. J and C go together. So it's going to be C. And then N and B go together. So B. And this would be by angle. All right, next. So this one's an interesting one. We've got that these angles are congruent, right? But that's really the only thing that helps us out here. We do know that these two sides are congruent, but that doesn't tell us anything about the relationship between the two triangles. However, this is a very interesting one. This is isosceles. So these opposite angles are congruent. All right. And this is isosceles. So these opposite angles are congruent with each other. Well, With isosceles triangles, if these two are congruent and they're isosceles, that means that these other two have to be congruent with each other. So we could say that, you know, this angle is congruent to this angle. Angle A is congruent to angle R. And then we could say that angle B is congruent to angle C. So we'll say triangle ABX is similar to triangle, and then of course we're just going to follow the same pattern, triangle RCX. Because these two are congruent, your similarity statement might have differed if you did this on your own, but this is how I did mine. All right. Oh, and this one would be by angle, sorry. We didn't really prove any sides proportional there. All right, this one is very interesting. So you see how in this triangle, it's got all congruent sides? That means that it's an equilateral triangle. In all equilateral triangles, the angles are 60 because all the angles are congruent and it has to be 3 angles. So you would do 180 minus, or 180 divided by 3 gives you 60. Same thing here. If we look at this other triangle, it's an equilateral triangle. So these are all 60, 60, 60. And it's going to be an angle similarity. Now, in an equilateral triangle, the similarity statement could be written however the heck you want. Right, we could say like this side goes with that. Because all the angles are congruent, all the sides are proportional. So it's a little bit easier to do it for this one. So say ABC is similar to triangle XYZ. Very nice. All right, next. We are trying to set up proportions. So let's go ahead. We're looking at triangle. We've got this number 8 here. So we're going to go ahead and try and set this triangle up. We've got a bit small triangle. And then we've got a bigger triangle. All right. So looking at the small triangle, or actually, we'll do our big triangle first. We've got 150, and that's going to go with the 12 on our small triangle. And then we've got X, which is going to go with the 8. So we can do big over small. We'll do 150 over 12 equals X over 8. So we get 1200 equals 12X divided by 12. Divided by 12 is going to give you 100. All right. This one's a little bit trickier. So we've definitely got vertical angles going on here. So that means that these are congruent, so the sides opposite them would have to be the proportional ones, right? And then we know that these angles are congruent, so the sides opposite them would have to be proportional. So this is very important. This is tricky. Right, the sides, if you've got two congruent angles, the sides opposite them are going to be the proportional ones. So we can set up a proportion here. We'll do 18 over 12 equals X over 15. Which is going to give us 270 equals 12X, which gives us 45 over 2, or 22.5. All right, next one. So again, we've got our congruent angles. Opposite sides are proportional. Oh, and I guess, or we have to, yeah, okay. And then it would mean, since these are both 90, it would mean that these guys would go together. Hence, the only ones left to go together would be the 7 and the 35. So we'll go ahead. We'll do triangle 1 over triangle 2. We get 6 over X equals 7 over 35. So you get 6 times 35 is 210. Divide by 7, and you get X is 30. Not 3, 30. All right, next. we've got this angle goes with this side. This angle goes with this side. These angles go together. And these angles and this side go together. All right. So we definitely want to make sure that we put an x in there because we're trying to solve for x. So we've got 1 and 2. So let's do x over 8 equals, we'll say 6 over 4. So you're going to cross multiply, you get 4x equals, and then 8 times 6 gives you 48. Divide by 4 and you get x is 12. All right. So next it says, are the pairs of triangles similar? If so, write a postulate or theorem that allows you to conclude that they are similar. All right, so let's go ahead and try number 12. So again, our options are angle, angle, side, side, and such. Angle, angle, side, and side, side. This one's interesting. I feel like this x didn't need to be here. But anywho, we've got two angles congruent, right? So this would just be similar by angle, angle. All right, and if we're writing a similarity statement, the A goes with the Z, the B goes with the Y, so then the C and the X go together. So you would write triangle ABC is similar to triangle ZYX. We've got this next one. So we've got side, side, side. So we're going to try and use side, side, side to prove these. And if you recall, you need to put the big side of the big triangle over the biggest side of the small triangle. Then you're going to do the next biggest side of the big triangle over the next biggest side of the small triangle. Next biggest side over next biggest side. So when you plug these in, you get 13 divided by 6, which gives me 2.16 repeating. Then I do 10 divided by 5, which gives me 2. And I do 8 divided by 4, which gives me 2. Even though I have two sides that are proportional, this side makes it not work. It's not proportional. Since this doesn't equal that, you would say not similar. All right, all those proportions need to equal each other. And then you can't write a similarity statement because they're not similar. All right, next, let's go ahead, let's find the missing angles here. So let's see what C is. We do 180 minus 50 minus 20. And I get 110. So we can see here, got two angles congruent, so we can do angle, angle. So let's do triangle ACB is similar to triangle RTS, right? Because we went, these guys go together, these guys go together, and these guys go together. All right, and I do want to point out there is multiple ways you can write a similarity statement. They just need to be in the correct order. All right, we're getting there, my friends. So now we've got a side, an angle, and a side. So we're going to attempt to use side, angle, side. But let's go ahead. First, we need to set up the proportion. So take the biggest side of your big triangle, put it over the biggest side of your other triangle, and then do the next biggest side of your big triangle over the next biggest side of your other triangle. It gives me 2 and 2, which equal each other, so they are proportional. And we could say side, angle, side. Now we put these two guys together. We put, oops, that is blue, that is useless. And we put these two sides together, okay? So we can clearly see that N and U go together, M and T go together, and V and P go together. So we'll say triangle NMP is similar to triangle UTV. All right, last one here. We look and they only give us one angle. They didn't give us any other piece of information. You know, nothing about the sides, nothing about it being an isosceles triangle. So this one actually would be not similar. One angle is not enough information.